8, 7, 6, 4.
Because that goal will serve to organize and measure the best of our energies and skills.
Mankind is now on the verge of a great new era, the fusion economy. The prospect now exists for a global economic revolution, centered upon the high technology development of the Pacific region, driven by advanced infrastructure and the development of fusion power and technologies. In this series of videos, we present the path to this new era, one in which the common aims and common desires of all mankind will finally become the central objectives of international relations, and the creative powers unique to the human species can finally be unleashed across the globe and throughout the solar system. Fusion will provide an effectively unlimited supply of power, creating the basis for a fundamentally new economy. The benefits are not limited to simply providing more power for the processes which already exist in the current system. The fusion economy creates the basis for addressing resource needs far into the future. To understand this, we must first recognize that, for mankind, resources are not self-evident. They are not self-determined, and they are not actually natural. What are often sloppily called natural resources only become resources as a function of the technology and energy flux density of the economy. Start with a few examples. In the first half of the 19th century, the United States had a thriving fuel and chemical industry. Its primary feedstock? Whale oil. While the most common use was the burning of whale oil in lamps for lighting, applications extended as far as for soaps, margarine, lubricants, paint, varnish, and for the processing of textiles and ropes. By its peak mid-century, hundreds of ships were bringing millions of gallons of whale oil to the U.S. market each year. An immense amount of work. Finding, hunting, skinning, and processing the largest animals on the planet to provide light for your home. By the 1850s, methods were beginning to be developed to bring a new resource into use: petroleum. Prior to this, petroleum in the United States was relatively useless, even proving a nuisance when it filled mines dug for other purposes. When new methods for distillation of crude oil were developed, the separation and concentration of a new fuel became possible: kerosene. With this, the whale oil industry was quickly replaced, and the petrochemical industry was started. Technological advance drove the shift to an entirely new resource base. Or take one of the most important resources currently in use: fuel for the baseload electricity and energy needs of the economy. Pound for pound, the most energy-dense, efficient, and effective energy supplies immediately available are the fission fuels of uranium, thorium, and plutonium, tens of thousands of times more energy-dense than coal or oil. 100 years ago, these elements were nearly useless, and undistinguished constituents of dirt or rock, with some uranium finding a small role in tinting the color of glass. It was scientific discovery, the understanding of the atom, of fission processes, and of the equivalence of matter and energy discovered by Einstein, which changed these elements from nondescript components of dirt and rock into resources, specifically the best power source mankind had ever known, at least up to that point. Today, we sit on the verge of an even greater revolution: the ability to use a fuel an order of magnitude more energy-dense than uranium that promises to provide effectively unlimited power for all mankind. The physical resources for this are all around us. Isotopes of hydrogen produced from ocean water and rock. But the ability to turn such mundane things as these into a revolution for all mankind lies in the application of man's unique understanding of thermonuclear fusion. The fuel available in 1 gallon of ocean water can provide as much energy as 300 gallons of petroleum, fulfilling our energy needs far into the future. Take a related example, this time of elements we do know how to use, but which are not part of our resource base because of an inability to access them. The United States stretches across nearly 3.8 million square miles. If we examine any single cubic mile of dirt, on average it contains many times the United States' annual production of key resources. For tin, an average cubic mile of dirt contains 100 times the amount produced in the U.S. each year. For zinc, it is about 6 times. For iron, the element most used by weight, it's about 8 times. And for aluminum, our nondescript mile of Earth contains 200 times the U.S.'s annual production. Even with a fusion economy, we probably won't need to process random dirt. However, this example makes the point that the resources are there. It is up to us to figure out how to use them. The challenge results from a lack of technology, not of material. One technology illustrating the potentials of a fusion economy is the fusion torch. Already by the end of the 1960s, detailed designs showed that the extreme high temperatures of a fusion reaction could revolutionize materials processing. The plasma of a fusion reaction, reaching many millions of degrees, could be directed into a separate channel where any material could be dropped in and broken down into its constituent elements. These separated elements can then be concentrated and released as new raw materials. As a general concept, if the systems were eventually built to handle large volumes of material, effectively any trash or economic waste could be processed, perhaps allowing landfills to become excellent resources, containing materials we already use at concentrations far higher than those mined. Even before the development of the full-scale systems which depend upon a sustained fusion reaction, the technologies of the 1970s already made possible the creation of lower-temperature plasma torches and plasma processing systems fully capable of breaking down and reprocessing things ranging from hazardous chemical waste to spent nuclear fuel to scrap metal, extracting valuable raw materials from each. Going one step further, with the much higher energy levels available in a fusion economy, transmutation, changing one element into another, can become a regular economic practice. Many radioactive isotopes are extremely valuable for medical and other purposes. Those which are not useful can be transformed into other stable elements, eliminating the need for storage. If there are critical elements we need, some could be created from other, more abundant elements with similar weights. Gold can be converted into platinum, mercury can become gold, and alchemy can become part of the economy. These capabilities define the next step in the natural self-evolution of the human species. The history of mankind has been defined by successive transitions to higher forms of fire, driving the increased energy flux density of the economy per capita and per area. Now, we stand at the verge of the next step. With the shift to a full-scale fusion economy, mankind's existence on this planet is revolutionized as the concerns over limited power, limited fuel, and limited resources are subdued by the power of human scientific thought. technologies. In this series of videos, we present the path to this new era, one in which the common aims and common desires of all mankind will finally become the central objectives of international relations. And the fusion economy. The prospect now exists for a global economic revolution, centered upon the high technology development of the Pacific region, driven by advanced infrastructure and the development of fusion power and limited supply of power, creating the basis for a fundamentally new economy. The benefits are not limited to simply providing more power for the processes which already exist in the current system. The fusion economy
8, 7, 6, 4.
Because that goal will serve to organize and measure the best of our energies and skills.
Mankind is now on the verge of a great new era. Creative powers unique to the human species can finally be unleashed across the globe and throughout the solar system. Fusion will provide an effectively unlimited